June 2019, paper 1-2, O-level mathematics, syllabus D, 4024. Number 6A. Amount before tax, that's 100% relative terms, equivalent to $760. Tax 15%, amount after tax, so it's a reduction of 15% in relative terms. 100 minus 15, 85%. The question is to find this amount. So by proportion, 100% is equivalent to $760. 1%, 760 divided by 100, and then 85%, $760 divided by 100 times 85, which gives $646. That's the amount of the tax. The B part, amount invested $1,200 at a simple rate of interest, of 2% per year. So interest after 1 year is 2 upon 100 times 1200, that's $24. Now you're required to find the total amount after 6 years, so interest after 6 years. The fact it is simple, so you just multiply by 6. 6 times 24, $144. So the amount after 6 years, the total amount will be the amount invested plus the interest, which gives $1,344 after 6 months, total amount in the account. Now we can use a second method. The method 2, we use a formula. So the amount after time t is the principal, the amount invested now at time t equal to 0, times 1 plus r per 100, the rate of interest, times t, the time in years. So the amount after 6 years will be the principal, $1,200, into 1 plus 2 upon 100, that's the simple rate of interest, 2%, times 6 years. So 1200, 1 plus 12 upon 100, we expand, so it's 1200 plus 1200 times 12 upon 100, that's 144, 12 times 12, so in all $1,444 after 6 years, total amount after 6 years. Next, number 7. Number 7, you're required to find the fraction halfway between 3/5 and 3/4. So for any values, if you have x1 and x2, and you're required to find a value midway, halfway between these two values, we simply have to take the half of the sum, half of x1 plus x2. So in this case, will be half times 3 upon 5 plus 3 upon 4. The LCM actually of 5 and 4 is 20, so we need to have 20 in the denominator. We times 4 on this side, 4 on top, to look for an equivalent fraction. So half, it will be 12 out of 20, plus the same thing here, times 5, 15 out of 20. So it's half That's 27 upon 20. We multiply by half, so 1 times 27, 27, 2 times 20, 40. So 27 out of 40. That's a fraction halfway between 3/5 and 3/4. Number 8, in making a fruit juice is to water, that's a drink, in the ratio 3:5. The amount of water is 2 liters, so 1 liter equal to 1,000 milliliters. For 2 liters, that's 2,000 milliliters. That's 2,000 milliliters. You're required to find the amount of juice in milliliters. So 5 parts equivalent to 2,000 milliliters. 1 part, so 2,000 divided by 5, that's 400 milliliters. So for 3 parts, the amount of juice, 3 times 400, that's 1,200 milliliters. The amount of fruit juice actually, so the amount of fruit juice is 12,000 milliliters. Number 9. Number 9, you have to draw a speed time graph. So speed time graph. So along the vertical axis you have speed. So it's 10, 20, 30. That's the speed measured meters per second. And along the time axis, the horizontal axis, you have 0, 10, 20, 30, 40, 50, and 60. That's the time axis measured in seconds. Now, 3 pieces of information are given. The first information that the car starts from rest. Start means the time equal to 0. When time equal to 0, the speed is equal to 0. The fact that the car is at rest. So when time equal to 0, the speed is equal to 0. So you start with this point here, the origin. When time equal to 0, speed equal to 0. The second piece of information is that the car is moving constant acceleration for 20 seconds until reaches 50 meters per second, the speed of 50 meters per second. So when we talk of acceleration, actually, the gradient, we know the gradient of a speed time graph is equivalent to acceleration, that is increasing speed. Acceleration means the speed is increasing. So we need to find the gradient. So the gradient will give you the acceleration. So you've been told that after 20 seconds, the speed actually is 15. So here. And it is a positive gradient line. So it is upward sloping line. Acceleration is positive gradient. So it's upward sloping. For the first 20 seconds, it is accelerating until it reaches speed of 50 meters per second. So that is straight line from 0, 0 to 20, 15. And then the car moves at constant speed of 50 meters per second for 40 seconds. Constant speed of 15 meters per second for 40 seconds. So for 40 seconds, so here it is 20 plus 40, this gives 60. So up to 60, the speed remain at 15 here. Okay, so at 60, the speed is 15. So you have a straight line from 20, 15 to 60, 15. So it is moving at constant speed, no acceleration. The gradient actually is acceleration. So no acceleration here. The gradient is 0. No acceleration means constant speed. All right. So this is the shape of the speed time graph. The second part of it, you need to find the acceleration for the first 20 seconds. So I remove this part. We need to find the acceleration. So part B, acceleration, this is the gradient. So gradient will be y step divided by x step. Now the x step, this is the horizontal part of it. So we have time, measure in second, and then the vertical step, this is the y step, the speed, measure in meters per second. So if you look at the diagram, actually, the change in speed when time changes from 0 to 20 is from 0 to 15. So this is the y step, 15 meters per second, divided by change in time from 0 to 20, that's 20 seconds, giving 0.75 meters per second squared. Now, why it is meters per second squared? Because you take meters per second here, divided by second. I can write it like this, meters per second divided by second, s upon 1. So meters per second times 1 upon s, which gives m times 1m, and then s times s squared. That's indices. Or else you can write it as meters per second squared. Okay, so that's why it is meters per second squared. Now how to interpret this? So this acceleration of 0.75 meters per second squared can be written as 0.75 meters per second divided by 1 second, which implies that the speed is increasing at 0.75 meters per second for every second. Okay, that is speed is increasing at 0.75 meters per second for each second. For each second, the speed is increasing at this amount. That's acceleration, increasing speed. Number 10. Number 10 is about set. So you've got this one. You've got P, Q, and R. Okay, P, Q, and R. Right. And then the region shaded inside, we have this one shaded, the smaller one here, and the other one here. Now, if you look at the diagram, this is only P. This part is only P. Only P. That is, P is involved. You need to have P. This one is only R. Only R, meaning that R is involved. But the fact that you have this part, which is both in P and R, it implies that it's addition. You're just adding these two regions. That's union. Okay, because union means adding regions plus adding. So we take these two first. And then if you look at Q now, this part, only Q, you don't have Q actually. It's not shaded. Meaning that it's outside Q. That's Q dash. Outside Q, because you don't have this one shaded. Only Q is not shaded. It's outside Q then. And the fact that the region found in P and R, which is at the same time in Q, are not shaded, it implies that you're taking the overlapping part. It is outside Q, common with P and R. So it's intersection, not addition actually. It's overlapping regions. So it is intersection. So the answer is P, union R, intersect with Q dash outside Q. The region common with P union R, which is outside Q. That's the overlapping region. That's one way of doing it. There is another way. We go about it. Method 2. We draw it like that. So you have P, Q, R, and that's a universal set. That's region 1, region 2, region 3, region 4, 5, 6, 7, and then 8 outside. What you're going to do actually, we'll draw a table. That's a universal set. So we'll take regions, consider that regions 1, region 2, 3, 4, 5, 6, 7, and 8. Okay, that's a universal set composed of 8 regions. We look now, the fact that R in P, this is shaded, this one here, only P, that's only P, so we have to take P. P is composed of region 1, 2, 4, and 5. 1, 2, 4, and 5. And then the fact that this is shaded, region 7, implies that you have to take R. So R is composed of region 4, 5, 6, and 7. 4, 5, 6, and 7. Now, the fact you're taking both region, P and R, means you're adding these two regions. P union with R. So it's 1, 2, 4, you take only 1, 4, 5, 6, and 7. Right? Now we look at Q now. Q, the fact that you don't have 3 shaded means you have to take Q dash outside Q. Region found in Q, 2, 3, 5, 6. Therefore, 1, 4, 7, 8 are outside. 1, 4, 7, 8 are outside Q. Now, if you look at the diagram now, 1 is shaded, that's region 1. Region 4 is shaded, and region 7 is shaded. So we need to have, if you look at, you need to have 1, we need to have 4, and then 7. So it implies that we are taking only the overlapping part, overlapping region. It's not adding region because you don't have 2 here. You don't have 5, you don't have 6, you don't have 8. So it's just overlapping. So it's P union R intersect Q dash. It's P union R, we take the first one and this one. P union R intersect with Q dash. So this gives region 1, region 4, and region 7. So this is the answer. P union R intersection Q dash. Okay. We move to the B part now, 10b. The universal set is equal to x such that x is a positive number. So it's a real number which is positive. This is such that, this column. And then A, x such that x lies between 9 and 10. X is greater than 9 but less than 10. B, x is an irrational number, meaning that you can't convert it as a fraction, like root 2 for example. You can't convert it as a fraction. It remains as decimal actually. Now the question is write down an element belonging to both A and B, A intersection B. So it should be an irrational number between 9 and 10, which is a positive real number. So between 9 and 10, we can take a square root of it. So the square root, just square this 9 and then take the root. That's root of 81. The same applies to 10. Square it and take the root of it, root of 100. So any root between root of 82 to root of 99. So I can take as answer root of 85, for example. So any root between root of 82 to root of 99 is an element of A intersection B. Or else could have taken a cube root. So what need to be done in this case, we'll just take the cube of 9 and then the cube root of it. So that's cube root of 7 to 9. The same applies to 10. You cube it and then to the cube root of it, cube root of 1000. So any cube root from cube root of 730 to cube root of 999 is an element of intersection B. So I could have taken cube root of 800.